All right, this is a quick video to explain how you can represent energy in a system using an energy transfer diagram. So we're going with the child sledding down the hill example. You always want to start with a sketch. So sketch first. So I've drawn a sketch of the child on the sled, and they're going to sled down. So I've labeled every object in the picture: child, sled, snow, and earth. I've also labeled the 2 times that I'm interested in. So the child starts at rest at the top, and by the time the child gets close to the bottom, they're moving pretty fast. All right. So once you've got your sketch done, the next thing you want is a system schema. Remember that the system schema needs to have every single object in the system represented inside its own little circle, and then you connect things that are touching each other or obviously interacting with a line. And then the last step is to draw a dotted line around your system. So here I picked as my system the child and the sled. And I have the child and the sled interacting with the snow and the earth. Remember, we talked about friction and whether we consider it or not. In this case, we're going to ignore it. So since there's no friction, that means we consider it to be insignificant. We don't actually have an interaction between the child and sled and the snow. All right. So here comes the lull diagram. You want to draw a circle to represent the system, and you want to put inside the circle what your system is. So just like in my system scheme, I've got the child and the sled, and then you want an L for the first instant, which is at rest at the top. See, I've labeled that here, at rest at the top. And then you want another L for the last instant, so just before the bottom. And then I've written down every single kind of energy we could possibly have underneath the L's, because these are the categories we're considering. All right, so at the top, does the child and sled system have kinetic energy? Are they moving? No, we're going to put an X here. At the top, does the child and sled have gravitational energy? The answer is no, because Earth is not in the system. Notice that Earth is outside the system. You can only have gravitational energy stored in the Earth-child-sled interaction if the Earth is in the system. Do we have elastic energy? We don't have anything springy here, so no. Do we have thermal energy? We're totally ignoring friction, and it's at the beginning, so no. So we got no energy in the system in the beginning. Okay, so in the book, we talked about how the Earth is pulling on the child and sled. That's this interaction right here, ding, 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 ding. So there is some possible transfer of energy between the Earth and the child sled system. We think the Earth is going to pull them down and make them go faster, so we're going to put a big arrow here for Earth, and we're going to say, and just randomly because I picked, that the Earth puts in 3 blocks of energy. Okay, so 3 blocks of energy. Where does that energy go? Well, just before they get to the bottom, the child and sled are moving fast. And so that's a sign of kinetic energy. So those 3 blocks go into the kinetic energy pile. We still have no gravitational energy because the Earth is still not in our system. We have no springs, and we're ignoring friction. Remember, no friction, so we don't have any thermal energy. And there's our first LOL diagram, or energy transfer diagram.